This video is on the preparation of carbon-oxygen double bonds, or the carbonyl, via oxidation reactions. Oxidation reactions. Think back to Gen Chem. What did you learn? Oil rig, oxidation is loss, reduction is gain, or maybe you learned Leo says grrr, i.e. loss of electrons is oxidation, gain of electrons is reduction, whatever, unnecessary stuff. In organic, we don't worry about that kind of things. Oxidation is increasing the number of carbon-oxygen bonds, and reduction is decreasing the number of carbon-oxygen bonds. Or if you want to think about it, the increase in the number of carbon-hydrogen bonds. So for example, if we have this secondary alcohol, carbon has one single bond to an oxygen, 2 to carbons and 1 to hydrogen. Well, if we remove 2 hydrogens to give us a carbon with a double bond to an oxygen, we increase the number of carbon-oxygen bonds. Therefore, this is an oxidation. Whilst if we have a carbonyl and we add 2 hydrogens to it, we end up with a carbon with only 1 bond to oxygen. Therefore, it is a reduction. Pretty much any alcohol can be oxidized, and most carbonyls can be reduced to give you alcohols. But we'll focus on the oxidation, as this is an elimination reaction to form a carbon-oxygen double bond. So it turns out the oxidation reaction of alcohols is relatively finicky. If you have a primary alcohol, under mild conditions, you can form an aldehyde, whilst under harsh conditions, you will make a carboxylic acid. Furthermore, these same harsh conditions can also convert an aldehyde into a carboxylic acid. You will notice that that is also an oxidation, yet it's not an elimination anymore. Secondary alcohols, we can use mild or harsh conditions to give us a ketone. Ketones, however, cannot be further oxidized, whether it's under mild or harsh conditions. Tertiary alcohols do not react, and you cannot oxidize them. This is the reason why if you were to drink tertiary alcohol, you will remain drunk for a long time. Your body cannot oxidize and get rid of it. So what are mild conditions for oxidation? Well, these will include PCC, looks like this, or sodium hypochlorite in water and acetic acid. Both of those conditions, for example, could convert a secondary alcohol into a ketone, or this primary alcohol into this aldehyde. Harsh conditions involve potassium dichromate in sulfuric acid and water, or something like potassium permanganate, just straight. A derivative for these harsh conditions could also be sodium dichromate in sulfuric acid and water. Either way, recognize the conditions and apply them in your problems. So what would the product be for the following reaction? You may pause now. And here's the answer. Now, if we want to convert this alcohol into this aldehyde, what conditions would we need? You may pause now. And here's the answer. All right, looks like we're getting it.